Morning, kiddos. We're going to talk about gears today and torque and speed relationship. Um, this is a 84 teeth gear, and a 36 teeth gear. You determine the size and the ratio of the gears by the number of teeth they have. So this would be 84 to 36 ratio. Uh, uh, Gear ratio. This would be 84 to 84, which would be one ratio, basically, relationship with one another. For instance, if this gear was spinning and rotating this gear, they would rotate at the same speed. But what you'll notice is even numbers, the the gear that's being driven rotates the opposite direction. Odd numbers, they rotate the same direction. For instance, if this gear was rotating this way, and this would make this gear rotate the opposite way, but this would make the gear turn the same way because there's odd numbers. So if I rotate this gear that rotates this one, that rotates this one, they would be both turning in the same direction. But if this gear was rotating this gear would be in the opposite rotation of this gear. For instance, if this one was rotating clockwise, this one would be counterclockwise. But if I put this one in the middle, this one would rotate clockwise, counterclockwise, clockwise. So odd numbers, same direction. Even numbers, opposite direction of the driving gear. All right. Got it? No matter how long this chain is, if you had odd numbers, the last gear in the chain or the train would be going the same direction as the driving gear. But if it was even numbers, it'd be going counter to the driving gear. All right? Hopefully that's understandable. Also, we're going to talk about uh, torque and speed. One of the drawbacks is if you want more speed, you'll lose torque. The more torque you lose. If you want to gain more torque, you lose speed. You can't have both. You can have a balance between them, but you can't have one or the other. So if you want more torque, you lose speed. And if you want more speed, you lose torque. For instance, if you'll notice, if I put the motor connected to this gear and it was rotating this gear, I would do more turns before this does one complete turn, which in this case, this would give it torque. This gear would have a lot of torque, but it wouldn't rotate very fast. So I lost speed, but I gained torque. So when I take a smaller gear and I rotate a bigger gear, I gain torque, but I lose speed. But if I reverse that motion and put the motor on this one and it was rotating this one, by the time this one completes one rotation, I would do a bunch of rotations with this one. So I would gain speed, but I would lose torque. So if you get more torque, you lose speed. If you gain more torque, you would lose speed. If you gain more speed, you would lose torque. All right. So hopefully that's understandable. Determining the size, the ratio of the gears with each other will determine the balance of the torque and speed. But if you need a lot of torque and you want speed as well, uh, together like this, you would not gain a whole lot. Now there is some gear setups that you can kind of uh, possibly get the same. If you do it correctly, you can get some speed and torque out of it. But as 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 far as one chain or train that you have set up, then if you want more torque, you lose speed. If you want speed, you lose torque. All right. Hopefully that's understandable and understand the sizing of the gears. Again, if you need a little bit more information, just contact me and I will help you. Y'all have a good evening.